So we as scientists, for us, many of these methods in machine learning and artificial intelligence, so machine learning is just a set of algorithms which apply to solve specific problems. So you can think of many of these deep learning methods as universal ways to approximate complicated data sets, where you often have a huge dimensionalities in the problem, which means many degrees of freedom. Like when you train a large language models, which is one of the foundations for ChatGPT, you train trillions of parameters. So when you use these methods, you have the possibility in science to attack much, much larger problems. One of the huge scientific advances, which has consequences for us humans, is, I would say, in medical research. And in medical research, if you think of cancer treatment, the scan of images of a tumors is something which takes a long time. And if you go to an oncology department at the hospital, worldwide, it's irrespective of country. I've been asking these questions to my friends in Italy, in Spain, and so on, and they will always say that what they miss are pathologists. So the pathologist is the one, it takes actually a life to train somebody who can recognize tumors. So if you then can use machine learning and artificial intelligence, train models, which then can quickly see from the scan whether this is a benign or malignant tumor, then you can put that patient into a treatment pipeline as soon as possible. And then for the cases which are difficult, then you can have a pathologist coming in and look at the scans and eventually even operate near the tumor and see if this is a benign case or malignant case. But then the pathologist can really use the lifelong expertise on these specific dubious cases, and then you have trained reliable models which are able to identify whether that tumor is a benign or malignant one. That is a fantastic application of many of these machine learning and AI methods. For us doing physics, there is a lot of interesting set of applications which deal with everything from analysis of huge experimental data down to you using machine learning to design a better experiment. You can often tune, if you're doing particle physics experiments or nuclear physics experiments, where you impinge with a beam of particle, you can tune the beam of particle as the experiment goes on. Another very important aspect of machine learning and applied to things which have consequences for us is weather forecasting. Because in weather forecasting, you've probably seen that the weather forecasts over the years have gotten better and better, more precise. And that's simply because you have better computers and you can simulate and also acquire data for smaller regions, which means that the models become more precise. Now, for many of the more tricky problems like turbulence, you need a very high resolution. And this is where solving the equations which meteorologists solve, together with machine learning methods, can help in studying turbulence. So in my country, to have I come from Norway, and in northern Norway, when you go out fishing during the winter, if you have sudden cases of turbulence, then your boat can be covered by ice and the boat sinks. So to be able to predict turbulence properly is a fundamental problem for weather forecasting. So there are so many applications which, aid us in getting more insights about a scientific problem, but also makes life better for us, especially in medical treatment. You obviously have many more, shady things which can be misused. But if you look at the science applications, these tools actually promise a lot to us. There are already many applications which have improved, let's say, medical treatment. But if you look more on the societal aspect of it, what I am more interested in is that the population as a whole gains an insight in what these methods mean, so that they have a computational literacy. Because else you can use these models to deceive people. So understanding what their limits are is, in a way, at the long run, is something which is important for the way a society develops. So that this kind of knowledge is not something which belongs to just a small group of people. And we as civil servants, public servants, our mission is actually to give a country this kind of knowledge so that people can make own decisions based on their knowledge about specific methods. I think that is one of the other important societal aspects of new technologies like machine learning, artificial intelligence, so that you in a way demystify what these methods mean. That actually there is an algorithm which you often program, and the way this is set up can also have some biases. So that I don't know if you are aware of that case with Apple, who wanted to develop an automatic way of assigning people credit cards or Apple credit, and that was skewed towards the husband's position. And even if the woman, the wife, earned more money, she could be refused credit simply because she was a woman. So when they programmed the algorithms for giving you credit with Apple credit cards, there was a bias in the way it was programmed. So having an understanding of all these limits and also the pros and the cons is very, very important. And today, if you think of societal applications and implications, there's a lot of fear about how this is being misused for developing conspiracies, etc., etc. And that's where we as scientists and university teachers have an important role to play.